What methods can be used to trace the origin of sodium in a study like this are geochemical analyses, hydrogeochemical modeling, mineralogical assessments, and isotope tracing part of the scientific toolkit to distinguish between natural and human-driven salinity sources. How might the duration of agricultural use, spanning 30 years, compound the salinization problem over time? Does prolonged exposure to poor irrigation practices in a dry climate lead to irreversible changes in soil chemistry, loss of soil structure, or permanent damage to the land's productive potential? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does sodium salinization affect the economic and social sustainability of agriculture in the region? What are the implications for local farmers, crop choices, food security, and community resilience in the face of progressive land degradation? What types of vegetation are most affected in this region? Are native species, pasture grasses, or staple crops showing signs of decline due to sodium accumulation, and what visual or measurable symptoms indicate sodium stress in plants? How can identifying the source of sodium salinization inform policy or land management practices? Can it lead to better irrigation design, soil amendment use, alternative crop strategies, or rehabilitation programs that restore productivity and ecological balance in the region? Why is it essential to study both soil and water when examining salinization? How do these two systems interact in terms of salt movement, irrigation return flows, leaching dynamics, and seasonal variation in salinity levels? And why is an integrated approach critical for accurate diagnosis and intervention? How does the timescale of land use, specifically 30 years, help scientists understand the cumulative impact of irrigation under arid conditions, and what lessons can be learned from long-term observation in terms of how quickly or slowly salinization sets in, stabilizes, or accelerates? What indicators or thresholds are used to determine that salinization is significantly affecting crops and vegetation? Are there soil sodium adsorption ratios, SAR, electrical conductivity levels, or crop performance metrics that clearly show when the land is deteriorating due to excess sodium? How do changes in vegetation and crop productivity feedback into the salinization process? Does reduced plant cover contribute to greater evaporation, less organic matter input, and further loss of soil structure, creating a vicious cycle of degradation in arid agricultural systems? How can future research build on the findings of this study? What areas need further exploration in terms of climate impacts, alternative water management, or biological adaptation to salinity? And how might new technologies or policies help reverse or stabilize the effects of sodium salinization in vulnerable regions like Tierra Nueva?